This video is for class 7 physics, and today we are doing thermal expansion. Now it has been experimentally observed, okay, it is found through the experiment that when a substance, either it be solid, liquid or a gas, is heated, it expands, it grows in size, right? The volume increases or the length increases or the area increases, and when it is cooled it contracts. That means its length decreases or its area decreases or its volume will decrease. We will now consider the thermal expansion in solids, liquids and gases separately. In this video I will try to explain thermal expansion in solids and its consequences, right? So let us begin with this topic, thermal expansion in solids. Now, why will a substance expand on heating? Let us try to understand that first. So here we are trying to understand why should a substance expand on heating. Now, as you all know, the substance, you can take any random substance. Suppose I am taking a cube, right? Now this cube should be made up of many molecules, right? This cube should be made out of many molecules. So I am considering some molecules inside the cube. I cannot draw all of them, but still I am considering few of them. Now as you notice here, there are some spaces between the molecules. There are some spaces between the molecules. This space here, this space here, this space here, they are known as intermolecular spaces. These spaces are known as intermolecular spaces, right? Now as we supply heat to the substance, when we start heating a substance, then what happens? This intermolecular spaces increases, right? As a result of this, the substance will grow in size. It increases from all the sides, right? So this is how the expansion takes place, right? Because of heating. Now, so increase in this space will result in expansion. I hope you understood why we have expansion. So let us go back to our book. So now thermal expansion in solids. Thermal expansion in solids. A solid has a definite shape. As you all know, this comes from the property of solids. When a solid is heated, it expands in all directions, as we have just seen with the help of a diagram. Hence the length, area and volume all increases on heating a solid. Now the increase in length of a solid is called linear expansion. The increase in area is called superficial expansion, whereas increase in volume is called cubical expansion. So basically there are three types of expansions, which are: number 1, linear expansion here; number 2, superficial expansion; and the last one, number 3, which is cubical expansion. So let us try to understand them one by one. Let us try to understand the first one, which was linear expansion. Right? Let us consider a wire. Okay, and suppose we heat it, we are supplying heat to the wire. Now what should happen? Obviously the wire will increase its length. As the increase in its breadth and the height, goes unnoticed, right? It goes unnoticed. So as you can see here, only the length is increasing, so only length increases or increase in length. So this is linear expansion. So anything anywhere when the length is increased, okay, is known as linear expansion, right? Now coming to the next part, that is point number 2, which was superficial expansion. Coming to the next point, point number 2, right? It was superficial expansion, right? It was superficial expansion. Now let us consider one metal sheet, okay? It is metal foil or metal sheet, right? Now suppose we heat this foil. Now what should happen? Obviously the length should increase and its breadth should also increase, thus resulting the increase in the area, so now the whole area has increased. So what has increased? Area has increased. So or I can say increase in area, right? Or I can say increase in area, sorry. So this kind of expansion is known as superficial expansion, when the area increases, when the total area increases, right? Now let's go to the third one, which is cubical expansion. Cubical expansion, right? Cubical expansion. Now let us consider a cube again, right? Now when we heat this cube, when we are supplying heat to this cube, now as you all know, its length should increase, okay, its breadth should increase, its height should also increase, okay. This is supposed to be height, breadth, and okay, this is the length. So all three are increasing: length, breadth, and height. So as a result, volume increases. So when the volume increases, it is known as cubical expansion. I hope you have understood cubical expansion also. Now we can go to the book again. Coming to the activity number 4, take a piece of iron wire, slip a cotton ring through the wire as shown here in the figure. Stretch the wire between the two vertical strands. These are the two vertical strands. Adjust the position of strands in such a way that the wire is just tight as shown in figure 5.7a. This is 5.7a. The wire is tight here, okay. Now what happens, there is another figure where it is heated, and you can see the wire has just made a loop, right? It just increase its length because of heating, right? So it can be seen with the help of this hook, as the hook is pulling it down, okay. So now let us try to understand what are its conclusion. Now heat the wire over a low flame using a burner or a candle as shown in the figure 5.7b. probably you have seen that. You will notice that the wire no longer remains taut, okay, but it becomes loose, right? So this should be tight. This indicated by the dangling ring. Dangling ring means like because of the ring, what happens is the wire just got looped. This shows that on heating the wire expands. Now remove the burner or a candle and allow the wire to cool, you'll notice that on cooling the wire contracts and again becomes tight. Okay, I hope you have understood this. Okay, some applications in daily life, now application of what? Of uh, expansion of what? Solid. Okay, expansion of solid. So number 1, the telephone and the electric wires when are connected in summer between the two poles. Suppose the construction is being done in summer, right? Being done in summer, they are kept loose, so that they may not break when they contract in winters. On the other hand, if the wires are connected in winter between the two poles, they are kept tight because they will expand in summer and might sag. Let us consider this figure here, right? So when the wires are laid or constructed during summer, right, so what happens is they are kept little bit loose, so that when they contract in winter, right, so that when they contract in winter, it will not get broken. What if they were already kept very tight? So when they contract, it might break. Okay, but in winter, when they are laid in winters, they are supposed to keep tight. Okay, the reason is when the summer comes, when this expands, right, when this expands, it becomes a bit loose. But if they are already kept loose during winter, so because of this expansion, it goes more down, right? So it might come in contact with so many objects which is going under this wire, right? I hope you have understood why this telephone wires or any kind of wires, when they are laid, okay, they are supposed to be laid in this particular fashion, that is loose during summer. When they are constructed during summer, they are supposed to be kept loose, and during winters, when they are constructed, it is supposed to be kept tight. Okay, I hope you have understood till here. Let us go to the second point. The second point reads as, in the construction of a breeze, steel gliders, okay, are used. One end of the glider or the gliders is fixed into the concrete or the brick pillars, and its other end is not fixed, but it is placed on rollers, right? The reason is that if there is any rise or fall in temperature of atmosphere, the glider can freely expand or contract without affecting the pillars. Okay, let us try to understand this. Here you can see the figure of a breeze. Okay, here we have a glider. This thing is called glider, this thing here, right? And it is kept on the roller at one side, such that because of rising temperature, suppose it gets heated up, okay, during summer, so if it expands, there is a gap you can see here, so glider will move here and the gap will be filled and it will be rolled on the rulers, right? But if there is no ruler, or if there are no rulers, then this brick wall might crack because of this expansion, right? And during winters, if it contracts also, so it can go back to its original position, right? I hope you have understood this glider and rulers concept and the gap concept, right? So let us go to the third point. So coming to the third point, which reads as, the wooden wheels of a bullock cart are fitted with iron tires, okay, to ensure that it does not get wear and tear very easily. To ensure a tight fit such that the iron ring doesn't come out of the tire, sorry, doesn't come out of the wheel, the tire is made slightly smaller in diameter than the wheel. So how to fit it? Okay, the tire is first heated, due to which it expands. The heated tire is then fitted on the wheel. When the tire cools, it contracts and makes a tight fit on the wheel. Okay, let's try to understand this also. So here you can see an image of wheel of a bullock cart. Okay, so this is the wooden part here as shown here, wooden wheel, and it has a steel rim outside or the iron tire. Okay, so what happens is, when the wheel is taken first, okay, suppose this is a wheel you are taking, right? The size of the tire taken will be a little bit smaller than compared to the wheel, little bit smaller compared to the wheel, right? But we have to hit this. Okay, when we hit, you all know it grows in size. So the hot tire is now slipped over this wooden wheel. Okay, and the cold water is poured on it such that when it contracts, it has a very tight grip on the wooden wheel, such that it has a very tight grip on the wooden wheel. Okay, I hope you have understood till here. Coming to the fourth point, the cement floor is not laid out in one piece. Okay, the cement floor is not laid out in one piece, otherwise it will crack due to the expansion in summer and contraction in winter. On the other hand, the floor is laid in small pieces with gaps in between to allow for the expansion during summer. However, glass strips can be placed in the gap. Okay, let us try to understand this point also. Okay, let us consider floor, right, such that it is placed solid floor. So what happens is, because of expansion in summer and contraction in winter, it might develop some kind of crack. Okay, but if the same floor is made from concrete tiles, okay, small gaps can be placed in between the concrete tiles, and this gap might be filled with the glass. Okay, so slowly we can fit the tiles, the concrete tiles. Okay, now small gaps should be left. We're talking about these gaps here. I am not completing the diagram. We're talking about these gaps here, right? Small gaps should be left in between the tiles. The reason is, if it expands also, right, if it goes in also, it has some space to go in, right, it has some space to go out. Okay, and if it contracts also, no problem, it has enough space to come back. Okay, I hope you have understood this also. Let us try to understand the next point. Coming to the next point, which is point number 5 here, the rails of a railway track are made of steel. While laying the railway track, a small gap is left between the two successive length of rails. The reason is that the rails expand in summer. The gap is provided to allow for its expansion. If no gap is left, the expansion in summer will cause the rails to bend sideways. This may result in train accidents. Okay, let us try to understand this point also. So coming to the figure, here you can see here, the small gaps are left in between the railway tracks. Okay, these are the railway tracks. Okay, so there is a small gap left when they are laid. Okay, a track is laid, a small gap is left in between the iron rails. Now what happens is, during summer, okay, this iron rail, or the, you can say the steel rail, and expands, and hence the gaps might be filled. Okay, and during winters the gap is not so big enough such that the wheel will get inside the gap. But if these gaps are not kept, what will happen? So if the gaps are not kept and is a straight, right, straight railway track, then what happens is, during summer what happens, it will expand, and since this railway track is getting expanded, so it will tend to bend, it will tend to bend, like we have seen that wire bending. Okay, so when this railway track bends, okay, so whenever a train passes over it, it might overturn itself, right? So I hope you have understood, okay, this point as well. Now coming to the last point of the topic, thermal expansion. So the sixth point, bimetallic strip. Bi means two, metallic means made out of metal. Okay, strip is kind of ruler, right? So a bimetallic strip which consists of two rods of same length but of different materials, say one is made out of iron, the other is made out of copper, riveted together means fixed together, right? Is commonly used in a thermostat. Now thermostat is an instrument which is used in your electrical gadgets for the power auto cut. Okay, like your iron, when you are ironing your clothes, when the iron reaches a particular temperature, the light goes off. It's just because of this thermostat present in that iron. A thermostat is a device used to control the temperature. A thermostat is used in electrical gadgets like refrigerator, like electric iron, oven, etc., your rice cooker and all. Okay, it has a thermostat. So let us try to see what see what bimetallic strip is. Okay, and we shall discuss more about thermostat in class 8. So here is a figure of a bimetallic strip. Okay, a bimetallic strip, this is a bimetallic strip, this is a bimetallic strip. Okay, it is made out of brass and iron. You can see they are riveted together. This thing is called riveting. Here they are fixed together. Okay, they are fixed together. Now because of heating, what happens is it will get bended. Okay, the reason is the brass expands more than iron. Okay, the brass expands more than iron. As the brass expands more than iron, so it makes the upper curve or the outer curve, and the iron is making the inner curve. As you all know, the inner curve will have less distance to cover, right? Now as brass expands more than iron, so the whole thing get curved this way as they are riveted together. Okay, and this can be used, this property can be used in a thermostat. Okay, I hope you have understood what bimetallic strip is and where it is used. Okay, this much for this video. Thank you so much.